Okay, today we're going to take a look at Module 2, Section 2. And as far as Module 2 is concerned, there is no test. There's just the 3 homework sections. When we get to Module 3, that Module 3 test is only over Module 3. Okay, so what you're actually doing in Module 2, you might see a problem or two from this module on the exam, on the final exam, but there won't be a Module 2 test per se. Okay, so the last time we met, we had taken a look at the graphs of sine and cosine. And I'm going to go back to the lecture notes section. And I believe we were in 8.6. And we had taken a look at the graphs of sine and cosine. We looked at a couple of model forms for sine. One of the basic model forms, it didn't contain like the vertical shift or the phase shift. And then we had taken a look at the model that actually has the vertical and the phase shift. The sine function is an odd function. The cosine function is an even function. Okay, those are the two important things that were actually in this little called a function capsule. Today, I'm going to take a look at 8.7. And in section 8.7, okay, which is similar to our module 2.2, we take a look at the other trig functions. So as I alluded to in the last class, the sine and cosine are continuous functions. That means you can put your pencil on the graph and trace the entire graph without removing the pencil from the paper. The other 4 functions are discontinuous. Right? So on this particular slide here we see there's actually 2 graphs embedded on one slide. So we take a look at the first graph. You notice that the red line, that is the sine curve. The sine and the cosecant are reciprocal functions. So the graph for the cosecant, you're going to notice it's the blue curve. Now this is what makes it discontinuous. If I were to try to trace this graph, I could trace one part of the graph and then I have to remove my pencil off of the paper to continue tracing the graph. This is a discontinuous graph. So just notice the shape that the cosecant function takes. The cosine and the secant are reciprocal functions. So taking a look at this second diagram, the red line is the cosine curve. The blue line is the secant curve. Both the period for the cosecant and the secant are 2 pi over b. And I'm going to write all of that down in a second. So now how do you graph the cosecant and the secant functions on the calculator? I'm going to go back to our all exam formula sheet for a second. And on the all exam formula sheet, the very first set of formulas that you see are the reciprocal formulas. And I'm just going to pull up the calculator. So notice that we do have a sine, a cosine. Blow that up a little bit. We do have a sine, a cosine, and a tangent. And we have a sine and cosine and tangent function. However, on the calculator, there is no cosecant, secant, or cotangent buttons. This sine to the negative first power, this is not a cosecant. This is actually an arc sine function. And we talked about, we use these arc sine or inverse sine functions to find angle measures. If you were asked, let's say, to find the cosecant of some angle, you would actually put that in your calculator as 1 divided by the sine. And I'm going to show some examples in just a second. And when you graph, if you're graphing a cosecant function, you must put that cosecant in as 1 divided by the sine. The secant is 1 divided by the cosine, and the cotangent is 1 divided by the tangent. Okay. So now here's some examples just using the calculator. Okay, so this just says evaluate the following using a calculator. So let's just say you're asked to find the cosecant of 30 degrees. So how would I actually put this in my calculator? Well, in order to put this into the calculator, I must use a reciprocal function. So cosecant is equal to 1 over the sine. So if I'm going to put this in my calculator, I have to put it in the calculator as 1 divided by the sine of 30 degrees. So I'm going to do that. So I'm going to turn this on. I'm going to make sure I am in degree mode because I'm putting in a degree measure. So in order to evaluate the cosecant of 30 degrees, I don't have a cosecant function. I have to enter it in as 1 divided by the sine of 30. And notice you get 2. If you look at the unit circle function values chart, okay, let me just find that. Okay, I'm going to go on the formula sheet and unit circle function values chart. And if we find 30 degrees, notice that the cosecant should be 2, right? So whenever you're asked for cosecant, secant, or cotangent, you must put in the reciprocals. So here's just another example. What is the tangent of 45, excuse me, the cotangent of 45 degrees? Right. Well, I don't have a cotangent function on my calculator, but I can use a reciprocal function, 1 divided by the tangent of 30 degrees. So if I put that in my calculator, 1 divided by the tangent of 30 degrees gives us like 1.73. All right. So when we take a look at the graphs of cosecant, secant, and cotangent, we must use the reciprocal identities. All right, so how will we graph cosecant x? All right, so I'm going to go into y equals, and I'm going to just clear out any functions that I have. And I must put in cosecant as 1 divided by the sine. So for y equals, I'm going to put 1 divided by the sine of x. I'm going to make sure that I am in radian mode. All right, 1 divided by the sine of x is cosecant. I'm going to hit zoom in 7. So notice zoom 7 is zoom trig. And this is what the graph looks like. So I just want to explain a couple things. On the calculator, the vertical lines that you see, that is not a part of the graph. This calculator is what's called dot connect the dot mode. So what's happening is it's taking a point. If I actually read this from left to right, as I first read it, notice it makes this U shape. So what the calculator is doing is it's taking this point at the very, very top and it's connected to the point way, way down here. Right? These vertical lines are actually called asymptotes. They're not a part of the graph. If I go into y equals, I'm going to scroll to the far left. If I click enter once, notice it just graphs, instead of a thin line, it'll graph a thicker line. If I hit enter again, this is if I'm graphing it greater than or greater than equal to equality. If I hit enter again, notice at the bottom half of the square is blinking. This represents less than or less than equal to if I'm graphing inequalities. If I hit enter again, this is some kind of trace thing going on. If I hit enter again, that's another trace. And if I hit enter for the last time, notice that instead of the dots being connected, they're like separated out. Now if I go back and graph, notice that those vertical lines are not actually a part of the graph. So what I just did was I took it out of connected dot mode and I put it in what's called dot mode. So I'm not sure if you want to do that every time you graph, but I want you to know that those vertical lines are not a part of the graph. Okay. So this is how you would graph cosecant x. We could also graph secant x. So in order to graph secant x, I have to use the reciprocal function, and I want to put this in as 1 divided by the cosine of x. And now if I regraph, notice the graph has been like shifted a little bit to the left. So this is one thing I concentrate on. I will look at the origin, and I will look at what my graph is doing right at the origin. So you're going to kind of see me do that. Because in this section, we mainly put the graph in our calculator, and then we match the calculator with the answer choices. So we won't graph any of these discontinuous functions by hand. We'll simply put them in the calculator and match with the given answer choices. All right, so with that being said, I'm going to take a look at the 8.7. So again, this is coming from the 8.7 in the set of lecture notes. Okay. I thought it was a secant on here. All right, so let's take a look at this example. We're just going to put it in the calculator and graph it. It says graph y is equal to, let me just write this down. Y is equal to 2 secant 1/2 x. Graph y is equal to 2 secant 1/2 x. Now, every trig function must carry an argument. Sometimes they'll put the argument in a set of parentheses, and sometimes they won't. So I'm going to put the argument in a set of parentheses. So I'm going to take this 1/2 x and just simply stick that in a set of parentheses. There is no secant function in our calculator, so I'm going to have to use a reciprocal function. So I'm going to keep my 2, right? And I'm going to rewrite right? So this is my 2. I just brought the 2 down. And now I'm going to rewrite secant as 1 over the cosine. So I'm going to rewrite the secant of 1/2 x as 1 divided by the cosine of 1/2 x. So notice the 1/2 x, it is still the argument of the cosine function. What I want to do from this point is I want to combine this into one term. So I can make 2 a fraction. So I'm going to just put that over 1. Now I'm going to multiply my numerators, multiply my denominators. So I want to have 2 divided by the cosine of 1/2 x. So this is what I must put into my calculator. All right, so the first thing I did was I changed secant to 1 divided by the cosine, and then I just combined everything to make one term. So now I'm going to put this into the calculator. So I have 2 divided by the cosine of 1/2 x. I'm going to just put that in as x divided by 2. Right. And if I graph, this is what the graph looks like.
I'm sorry, it was 2 minus cosine.
Yeah, 2 divided by the cosine. I just put in x over 2. You could put in 1/2 x. Oops. Or you can put in 0.5x, however you want to work that fraction out. But nonetheless, you would get the same graph. So mainly in this section is just knowing how to put the equations into the calculator. So any questions about that first one? Okay, let's take a look at this one. We're asked to graph 1/3 cosecant x minus pi. So just as we did in the previous example, I'm going to rewrite cosecant as 1 divided by the sine. Right, so I'm going to keep my 1/3. I'm going to rewrite cosecant as 1 divided by the sine of x minus pi. Right, because cosecant is equal to 1 divided by the sine. And now I'm just going to multiply my numerators and multiply my denominators. So this should be y is equal to 1 divided by 3 times the sine of x minus pi. And this is what we want to put into the calculator, but you have to be careful on this one. Okay. So I'm going to go to y equals. So this is 1 divided by. And then I'm going to use a set of parentheses for the denominator. And I'm going to explain why in a second. All right, so I'm going to use a parenthesis to close off my denominator. So this is 3 times the sine. And notice it gives me another begin parenthesis. I'm going to put in x minus pi. So now the pi button I'm using is actually above the caret, and it's a yellow function. All right, so I'm not putting in 3.14 or anything like that. I'm just using that true value for pi. I'm going to close off the sine argument, and I'm going to close off the denominator. So now if we graph, notice we have a discontinuous graph. Now here's what happened if you didn't put the set of parentheses. And this is what the calculator is going to do. It's going to divide 1 by 3, and then it's going to give you the sine function. So let's just say if I didn't use a set of parentheses for the denominator, it's going to give me a continuous graph instead of a discontinuous graph. So what's happening here, if you enter it in just like you see it without a set of parentheses, the calculator is going to divide, because it's using order operations. Please excuse my dear Aunt Sally. So it's going to divide 1 by 3, and then it's going to keep this sine term. But if you encapsulate it with the set of parentheses, you force it to simplify the bottom, you force it to simplify the top, and divide last. So if you add your set of parentheses, notice you get a discontinuous graph. So now we did not have to add a set of parentheses in the first graph, because in the first graph for my denominator, there's no operations, right? So when I say operation, that just means add, subtract, multiply, divide. But if you look at the second example, in the denominator, there is the operation of multiplication. All right, so you must use a set of parentheses. All right, so any questions on how to graph secant or cosecant? All right, the last two graphs are the graphs of tangent and cotangent. So here is the tangent function. So here's one thing about the tangent and the cotangent. Unlike the other 4 trig functions that had a period of 2 pi, the tangent has a period of pi. The cotangent also has a period of pi. So that means for the tangent and the cotangent, the formula for the period is pi over b. For sine, cosine, cosecant, and secant, the formula for the period is 2 pi over b. So that's where they differ. The tangent and the cotangent are pi over b. The other 4 trig functions are 2 pi over b. All right. So if we take a look back at the tangent, just one thing about the tangent. You read graphs just as you read sentences from left to right. No matter what graph you're reading, you always read it from left to right. If you take a look at the tangent graph, as you read this from left to right, this graph is going up. It's ascending. Right? As you read it from left to right, it's going up. For the cotangent graph, as you read it from left to right, notice that this graph is decreasing. It's going down from left to right. So when you're graphing the tangent and the cotangent, just be mindful that the tangent, it goes up from left to right, and then the cotangent function goes down from left to right. Okay. All right, so just knowing that, let's take a look at this last function. We're asked to graph 1/2 cosine 2x. Y is equal to 1/2 times the cosine, the cotangent of 2x. So here I'm going to just put my argument in a set of parentheses. So just as we've done before, I'm going to bring down my 1/2. I'm going to rewrite the cotangent of 2x as 1 divided by the tangent of 2x. I'm going to write this out as one fraction, so I'm going to multiply my numerators and multiply my denominators. And since we have more than one operation in the denominator, I must encase it in a set of parentheses. So now this is a cotangent graph, so when we graph it from and read it from left to right, it should go down. Okay, that's how we know we had a right graph. All right, so I'm going to go back into y equals. I'm going to clear that out. I'm going to put in 1 divided by. I'm going to put a begin parenthesis about my denominator. I'm going to put in 2 times the tangent. And notice it gives me a begin parenthesis for my argument. I'm going to put in 2x. I'm going to close off that argument and then close off the denominator. And now if we graph, and here again, these vertical lines are not a part of the graph, so I'm going to put it in dot mode. And it should just take those vertical lines out. All right. So notice as you read it from left to right, this graph is decreasing. All right, any questions about the other trig functions? All right, now we'll just take a look at some homework problems. Okay. Now the very first problem, I'm going to pull up the, where is it? Okay, I'm just going to pull up this. All right, so my very first problem says this graph, and I believe this is going to be similar for yours. It just says graph cosecant, the regular basic trig function, secant, cotangent, and tangent. So now this is what I was alluding to earlier about when I look at the graphs, I'm going to concentrate on what's going on like close to this origin. So for the first graph, remember we talked about tangent. As you read tangent from left to right, it goes up. And then cotangent, as you read it from left to right, it goes down. So this very first graph is actually going to be a graph of what? I believe it should be a graph of tangent x. Right? Because as you read it from left to right, this graph goes up. For at least my number C, as I read this from left to right, the graph goes down. This would be the graph of cotangent x. So tangent and cotangent, it just depends upon which, if the graph is ascending or descending. Now for sine and cosine, I want to concentrate on this origin. So let's see, if you look at the secant graph, notice that for the secant graph, for regular y is equal to secant x, didn't have any shifts or anything. This graph actually touches the y-axis. If I look at my cosecant x graph, notice that this graph does not touch the y-axis. So that's how I can kind of distinguish between the two. So the graph for graph B is going to be a what? Secant graph, right? Because if I look at my secant graph, it touches the y-axis. This graph touches the y-axis, so this is a secant graph. And then by process of elimination, D is going to be the cosecant. All right, so that's for problem number one, just matching up the basic function with its basic curve. Now, outside of number one, for example, question number two, it asks for the period and the phase shift. So let me write this down. Well, I guess I'll copy those. Okay, this is problem number two. All right, so we're asked to find the period and the phase shift, which is the horizontal shift of this function. If you're dealing with a tangent or a cotangent, the period is pi over b. So b is still the coefficient of x. So if I look at my problem, b is going to be 3. So the period is going to be pi over 3. Next, we're asked to find the phase shift. So now nothing's going to change with the phase shift. The only thing that changes is just the period when you're talking about the tangent and the cotangent. Remember that the phase shift, so y is equal to a times the tangent of bx plus c plus d. The amplitude, that's still the absolute value of a. The period is pi over b. The phase shift is negative c over b. And then the vertical shift is equal to d. Okay. So this is true for both the tangent and the cotangent. So let me just write that out. All right, so that's for both the tangent and the cotangent. Okay, and I want to shrink this up a little bit. Okay. All right, so if we find the phase shift, that's going to equal to negative c over b. So if I align this model form to my problem, c is going to be 24. B is going to be 3. So remember that there is a negative from my formula. I'm going to put C, which is 24, over B, which is 3. So my phase shift should be negative 8. All right, so for number 2, the phase shift is pi over 3. Excuse me, the period is pi over 3, and the phase shift is negative 8. Number 3, it says find the period and the phase shift for the function 3 times the cosecant of pi over 4x plus pi. All right, so let's take a look at that one. All right, so since this is a secant function, the period is 2 pi over b. And b is going to be the coefficient of x, which is pi over 4. So I'm going to write this out as 2 pi over 1 all over pi over 4. So I'm actually doing this so I can use that formula to simplify a complex fraction. So I made 2 pi fraction. I simply put 2 pi over 1. My denominator is a fraction, pi over 4. So just remember that formula says if a over b is equal to c over d, then you can cross multiply. That's that cross product property. Well, this is the okay, I'm in the wrong class. I'm sorry about that. If a over if a over b all over c over d. So this is a complex fraction. It means that I have a fractional bar, and in the numerator I have a fraction, and in the denominator I have a fraction. If this is my setup, I can multiply my very top and my very bottom, so I can multiply a times d, and then I can multiply the bottom of the top and the top of the bottom. Right. So I'm just going to multiply 2 pi times 4, and that's going to be 8 pi, and that goes in the numerator. I'm going to multiply 1 times pi, that gives me pi. The pi's are going to cancel, so the period should be 8. We're also asked to find the phase shift. So the phase shift is equal to negative c over b. And if I align that to my problem, c is going to be pi. B is going to be pi over 4. Right, so this is negative. Right? And then I have my main fractional bar. In the numerator, I have c, so I'm going to write pi as pi over 1. In the denominator, b is going to be equal to pi over 4. So if I multiply the very top and the very bottom, I get 4 pi. If I multiply the bottom of the top and the top of the bottom, 1 times pi is pi. The pi's cancel, so we have a phase shift of negative 4. So just going back, the period is 8 and the phase shift is negative 4. So I believe there was only two problems where they asked you for the period and the phase shift. Just keep in mind for the tangent and the cotangent, the formula for the period is pi over b. All right, now the rest of the problems, you mainly put it in your calculator and match the calculator to the answer choices. All right. So let's take a look at, well, this is at least my number 4. So now this is a tangent, and I do have a tangent function on my calculator. So I don't have to use any reciprocal functions. So I'm going to put this in as 2 times the tangent of pi. So here again, I'm using the true value for pi times x plus 2, and I'm going to close off the argument for tangent. So now here's where you got to make your graph match up with the answer choices. Notice if I look at my scales, my x scale goes from -3 to +3. It goes in increments of 1. My y-axis goes from 1 to 5, and it goes in increments of 1. So I'm going to scale my computer, my calculator, exactly like the answer choices. So from this point, I want to go into window. So now here's what you see in window. You see x minimum. So x minimum would be the smallest x value on my graph, which is -3. So make sure you put in the negative and not the minus. So I put in -3 for my smallest value on my x-axis. For my x max, I'm going to put +3. Where it says x scale, that's just simply the scale for x, and this scale is going by ones, right? 1, 2, 3, and then -1, -2, -3. So my x scale is 1. My y minimum, that's the smallest y value on my graph, which is -5. Oops. Which is -5. The largest value on my y-axis is +5. My y scale is 1, and always leave this x resolution at 1. Okay, just never change that x resolution. And now if we graph, this is what it gives us. Okay. So now I'm going to take the lines away, and this is what the graph should look like. So now this is how I usually line them up with the answer choices. I'm still going to concentrate on this y-axis, and it looks like this is a tangent graph as it increases as you read it from left to right. But if we take a look at this particular graph, that like fits this. It doesn't quite hit the y-axis. It's like really close, but never touches. This answer choice is a little bit different than our answer choice. If I scroll down, notice that this third answer choice, it actually goes past the y-axis. And then for our last, well, my last answer choice is like not even close to the y-axis. So my best possible answer here is going to be A. So the thing about these is you have to go into this window section and you have to adjust your x, y minimum, x and y maximum, and possibly your scale. All right, so that was problem number 4, and we will take a look at another one. Number 6, or at least my number 6. It says graph cosecant of pi x minus 1. So I don't have a cosecant function on my calculator. I have to enter this in as 1 divided by the sine of pi x minus 1. Right. If I take a look at my x and y axis, it seems like this x minimum is -2. The x max is +4. And it looks like the increments for the x-axis are 1. My y minimum is still -5. My y max is +5. My y scale is still 1. And now if we graph, and I'm going to take the lines out. So here again, in order to pick out the right answer, I'm going to concentrate on this origin. So it looks like if I'm looking at the right graph, the bottom part of my graph should touch the y-axis. So this is definitely not it, because that the bottom part doesn't touch the y-axis at all. If I scroll down some, this is not the right answer choice because it doesn't touch. And let me see, am I okay? The sine is cosecant is 1 divided by the sine of pi x minus 1. -2, 4. That scale is 1. -5, +5. The scale is 1. And I'm actually not seeing the right answer choice. Let me check. I'm in degree mode. I'm in radian mode. Okay. Because I am using radian measure. 1 divided by the sine of pi x minus 1. That's the right function. Is anybody getting something different? Pi x minus 1. That's the sine of pi x minus 1. That's the right function. I did graph. I don't know why it's not lining up exactly. Let me check something else. Well, there wouldn't be degree because I'm not in degree mode. And it's saying that this one is the right answer, but that can't be right. Oh, okay, I think I see what's going on. Okay. Let me change this back to... they didn't put this part. That was kind of dirty. Notice that they didn't put this. This is what I was looking for. But they have this and that. So I didn't do these before class, but I'm noticing I concentrate on the middle. Sometimes that middle may not actually be on the graph. Because instead of showing, what I'm seeing is only showing, I'm noticing that for each one of these, it's only showing two parts of the graph. So keep that in mind. They may not show you what's close. So they've changed that since last year. All right, so this one would actually be, I believe that would be D. That's 1, 2. So between 1 and 2, I'm sorry, that should be C. Okay. Yeah. So what I did was, where is it? Right here. For this graph, notice that this thing bends close to 1. So this is 1, and I can see where it has that bend. And then it has another bend in between 1 and 2. Right. So that would put this one as the correct one. Right. So let's do one more. The very last problem, it is 2 times the cotangent of pi x plus 1. Cotangent of pi x plus 1. Y equals to 2 times the cotangent of pi x plus 1. All right. So I'm going to keep 2. That's my multiplier. I'm going to rewrite the cotangent as 1 divided by the tangent of pi x plus 1. So this is going to equal to 2 over the tangent of pi x plus 1. So I'm going to put that into the calculator. 2 divided by the tangent of pi x plus 1. All right, so when we graph, I believe this one's going to be D. All right, so for this one, I looked at what was close to the origin, and it looked like that was D. So sometimes they may be missing parts of the graph, so keep that in mind.